I get a fair amount of questions about dust collection ductwork. Some from folks who think that the size of the ducts don't matter at all, and others who think that the bigger the ductwork, the better. Both points of view, though, can lead to a massive waste of money and loads of regret. I've learned that the hard way. So today, I just want to offer a simple, easy to understand explanation of this one part of the larger dust collection subject, specifically why the size of your dust collection hoses and ducts do matter, and what's right for your shop may not be what you think. I think this is best broken down into 4 factors: volume, velocity, resistance, and pressure. You must balance these 4 factors between your ductwork, your tool dust ports, and the capabilities of your vacuum or your dust collector. It is very important to understand this before you spend any money on dust collection equipment or ductwork. So let's consider these factors quickly, one at a time, beginning with volume. Air may be invisible, but it occupies space. A balloon, for example, has to stretch to create more space as the volume of air inside it increases. A dust collection hose or pipe can't expand like a balloon. It can only hold so much air within its walls. While it's true that air can be compressed, it takes a lot more pressure to substantially compress air than a wood dust collector generally can generate. So the only way to really increase the volume limitations of your duct sizes is to use larger ducts or larger hoses. Air volume, or airflow, is measured in cubic feet per minute, CFM. Generally, a 4-inch duct can accommodate 4 times the air volume as a 2-inch duct, and a 6-inch duct can accommodate about twice the volume as a 4-inch duct. Don't forget that the air isn't the only thing inside your ducts and hoses. Sawdust and wood chips also compete for that space with the air. But before you go out and you buy the biggest PVC pipe and hoses you can find, consider velocity. While it takes a certain volume of airflow to gather the dust and the chips up from your tools, it also takes a certain amount of air velocity to keep those chips suspended and moving through the airstream on their way to the collection bin. If the air velocity is insufficient, dust will drop out of the airstream and it'll pile up inside your ducts. You might test this principle by blowing sawdust off your bench through a drinking straw, then trying the same thing, except this time blowing through a larger cardboard tube like you'd find in a roll of paper towels. The smaller diameter of the straw obviously restricts the volume of airflow that can go through it compared to the larger tube. But the velocity of the air coming out of the smaller straw is much greater and it moves more dust. To compensate for the larger tube, you would have to increase the volume of air from your lungs, basically blow a lot harder to move the same amount of dust. The key points are, if the volume of air is the same, you will get more velocity from a smaller duct. Likewise, if you increase the size of the duct, you will need more volume to maintain the same velocity. Now let's talk about resistance. If you look at the specs on your vacuum or your dust collector, you're likely to see a cubic feet per minute or CFM rating. That indicates the volume it can move when the blower is completely unresisted. But in the real world, we add all sorts of resistance to our dust collection systems. So focusing again just on the ducts and the hoses, every bend and turn, every rib in the hose, even the walls of the ducts themselves along their length add resistance. Resistance slows velocity. And as I explained, velocity is what keeps the chips moving. So, in our first section we learned that volume is closely related to velocity. Now we learned that velocity is closely related to resistance. And in our final factor we learned that resistance is closely related to pressure. It takes more pressure to push an equal amount of air through a smaller space than a larger one. You might test this by drinking water through a regular straw as compared to those little cocktail straws. You have to suck a lot harder on the latter, and even then you won't drink as much volume because your lungs are not capable of generating a lot of negative pressure. Blower-style dust collectors, such as the big cyclones or the single-stage Harbor Freight style ones, they produce very little static pressure. So like your lungs, they struggle more when you connect them to smaller ductwork and hoses. Vacuum cleaners, on the other hand, generate vastly more static pressure, and they work better when you connect them with smaller hoses and ducts. So we've covered our 4 points, and clearly you see you have to find the right balance between those 4 factors based upon the system you have. Take a shop vacuum, for example. Shop vacuums typically come with 2.5-inch or smaller hoses for a reason. They're not designed to move enough air volume to maintain sufficient velocity through the larger ducts to keep that dust moving. But they do generate enough static pressure to pull a decent amount of volume through a small hose or a small dust port on a tool. A blower style dust collector, on the other hand, like your Harbor Freight dust collectors or your big cyclones, don't generate enough static pressure to pull enough volume through a small hose or a dust port to effectively collect sawdust and chips from your tool. But if you increase the size of the ducts or the hoses or the tool ports, you remove the volume restrictions and you dramatically increase that type of system's effectiveness until you reach the system's tipping point, where the size of the blower can no longer move enough volume of air to maintain the velocity required to keep the dust moving in the ducts. I know this is sounding a little bit complicated, so let me simplify it as much as possible. Big 6-inch ducts go best with big dust collectors. Medium 4-inch ducts go best with medium dust collectors. Shop vacuums go best with little hoses. And all of them work better with as little added resistance as possible from excessive duct length, bends, or corrugated hoses. Anytime you mix up those duct sizes, as you sometimes have to do when you build a shop dust collection system, you have to deal with the changes in performance that I just outlined in those principles. So let's apply that to some real-world examples. Here in my shop, in the main area, I have a powerful cyclone system with a big blower that can move a lot of volume. So I used large 6-inch ducts to accommodate that volume. Some of my tools, though, have 4-inch ports on them. I'm obviously not going to get my maximum airflow through those 4-inch ports, but I have to reduce down to them. Still, I use the 6-inch on the main ducts because I do have other larger connections in the shop, and I also have some tools that have dual 4-inch connections. So I need the larger main duct to handle the combined air volume from those dual connections. In fact, with a big duct like that, I have to leave 2 4-inch lines open at all times because I need to get enough airflow passing through the 6-inch duct to maintain the velocity I need to keep the dust moving and the ducts clear. In the corner workshop over here, I have a Harbor Freight dust collector. That has 2 4-inch ports on the bottom, but they're not meant to be open at the same time. It's a smaller system that moves significantly less air, not enough to maintain the velocity I need to keep 6-inch ducts clear. If I were to connect that to some ductwork, it would have to be 4-inch pipe. And I couldn't add too many bends or much flex hose that would further resist its modest airflow. Because both the Harbor Freight single-stage system and the big Clearview Cyclone system are blower-type dust collectors, they generate low static pressure. So I avoid reducing them down to really small hoses and dust ports if at all possible. The exception to that is on the router tables, where you have a 4-inch port on the bottom that tees off to a 2.5-inch on the top. I do use those, but that's out of convenience. Frankly, a shop vacuum would be better for that upper fence connection, and it would certainly be better for small handheld power tools like sanders, because shop vacs have high static pressure that can overcome the volume restrictions to a greater extent from those small ports than the dust collectors can. Of course, this just scratches the surface of shop dust collection. There are many more things to consider, and I've made a lot of videos on this subject. I'll link to some of them below. See you next time. We couldn't do what we do without folks like the Bushy family over at Clearview Cyclones. Not only do they make the best dust collection cyclones on the market, but they're woodworkers supporting woodworkers. They're the sponsor of this video, and I really hope you'll thank them by visiting their website and using our discount code below this video.